For chapter 4, we'll introduce the trail layers, including the optical layer and electric layer. And another one will introduce the maintenance signal used in the OTN. So first, let's look at the OTN trail layers. As you can see here, we have the in-band management and out-band management. For in-band management, that means for electric layer. So this is the OTUK overhead. We have the OPUK overhead, ODUK overhead, and OTUK overhead. And here we have the frame alignment signal. So this is the electric layer. And for here, we have the optical layer. So we have the OTS, OMS, and OCH. So as you can see, in the OTN, we have different trails. So for these trails, we divide into the optical layer and electric layer. So for the OPUK, ODUK, and OTUK, they belongs to the electric layer signals. And for the OTS, OMS, and OCH, they belongs to the optical layer signals. And here we show you one example. We have the application from the one side to another one, from the OTM to another end, we have the OTM. And in the middle, we have the OLA station, and we have the OADM, optical add and drop. This OADM can be the FORDM or can use RODM. So from this configuration, for example, we need to transmit the client services from the OTM to another OTM. And for this topology, we have 3 OCH from this OTM to this OTN cross connection. So this is one OCH. Another OCH is between here. So for this application, because our client signal is from the OTM to another OTM, so when we use the overhead, so we first use the end-to-end PM for the ODUK PM path monitoring. And because here we have 3 OCH, for the OCH, we can use the OTUK SM section monitoring. So you can find from this OTN boundary to the middle one, here we can use the OTUK SM. And here we have another OTUK SM. So totally, because here we have 3 OCH, so we have 3 parts of the OTUK SM. And also, we can define the TCMI according to the requirements. For example, in this case, we define from end to end, we use the TCM1 for user QoS monitoring. And then we define between the OTM to this OTM, we define the TCM2. So this one was used from the NI to NI for the domain-to-domain monitoring. Another part here, we use the OTM to this OTM, we use another TCM2. So for this TCM2, it was for the cascading. Okay. And here, for the detailed overhead, we already introduced in the previous course. So next, we can see the OTN trails again. And for this OTN trails, we have client, ODUK. Client, you can consider it's similar to the OPUK. And here we take the OTU board, for example. Also, we can use the tributary board plus the line unit board. So you'll find for the OPUK or for the ODUK, it's from the O2 to the far end O2, or from the tributary to the far end tributary board. And for the OTUK, it's from the O2 board or from the line unit board to the far end O2 board or the line unit board. And for the OCH, also it's from the O2 board to the far end O2 board. For the OMS, it's between the optical multiplexer and optical demultiplexer. So in our DWDM application, so the OMS, it will be between the M40, V, and D40. For the OTS, it's between the FIU to FIU. And also, if we use the optical supervisory channel, so here we have the OSC signal. So let's make a conclusion. For the client ODUK, O2K, they are the electric layer trails. For the OCH, OMS, OTS, and OSC, they are the optical layer trails. So next, let's look at the maintenance signal for the electric layer. And here we have the function for the management. For example, the first one, we have the alignment monitoring. So for this signal, we can use LOF or LOM. LOF means loss of frame. LOM means loss of the multi-frame. So for the OTUK and ODUKP, we can support it. For the ODUKT, cannot support. And next, it's for the connectivity monitoring, TTI, trace identifier. As we know, for the OTUK-SM and for the ODUK-PM and ODUK-TCMI, we have the TTI, so we can support in all the network layer. And another part is for the maintenance signals. We have the AIS, OCI, LCK, LTC, BDI, BI, IE, or BIAE. For the first three maintenance signals, we learned in the previous course that we can set the statures of the 3 bits value. For example, if the AIS, that means all the 3 bits, the value will be 1. Okay, so here you can find OTUK, ODUK, PM, and ODUK, TCMI, all can support it. Similar, you can do check for other maintenance signals, whether in the ODUK layer or in the O2K layer, whether we can support it. And last one is for the signal quality monitoring. It was used for the BIP8 error detection. So here you can find in the OTUK-SM, in the ODUK-PM, and the ODUK-TCMI, we can support it. Okay, so next we are to explain to you the maintenance signal one by one. Okay, so first you can see the maintenance signal, that is the AIS, alarm indication signal. So this one is transmitted from the ODUK, ODUKP, ODUKT, and client CBR to the downstream direction. So here it's very important. The AIS is transmitted to the downstream direction to indicate that the upstream defects have been detected and to suppress the defects and failures detected by the downstream due to the transmission interruption of the upstream signals. So this is the application for the AIS. And here we mentioned about the OTUK AIS and the CBR AIS, how they works. So first one, OTUK AIS is used to support the new service layer in the future. Currently, only detecting this signal is required, but generating this signal is not required. Another one, CBR AIS is generated in the ODUK or CBRX adaptation sync function. If this signal is received by the SDH, it's detected as a loss of frame alarm. And here we continue to introduce this maintenance signal. So for the AIS, when we find the AIS, it happened, so we should check the status bits. Okay, if all the value is 1, that we should insert the AIS, and we insert the overheads of the PM and 6 TCM layers and all the payloads to 1. So here I have 2 precautions. In the case of the adaptation sync function from the O2 to the ODU, the ODUKS is inserted when the service layer fails. In the case of the ODUKT termination sync function, in the operation mode, the ODUKS is inserted after the LCK, OCI, and TIM are detected. Whether to insert AIS upon the detection of TIM is configurable. So if you want to clear the AIS, so we should make sure the status bits 111, we should clear it first. Another maintenance signal, that is the BDI, means backward defect indication. And here you will find the OTS And OMS BDIs used BDI-P and BDI-O to indicate backward defects of payload and overhead, respectively. If a remote defect is detected for X milliseconds, indicating that OOS is inserted in BDI. A BDI is generated if a remote defect is detected for Y milliseconds, that the upstream defect causing the OS insertion in BDIP is cleared. The BDIP is cleared. Values of X and Y require future research. And next is the BDI for the electric layer. So here we have the OTUK, ODUKP, and ODUKT BDIs. If all the value for BDI is set to 1, that indicates an OTUK or ODUK backward defect. Otherwise, all the value should be 0. And last one, the BDI must be cleared under signal failure conditions. So this is the introduction for the backward defect indication. And next, we introduce another OTN maintenance signal, that is OCI, means open connection indication. As you can see here, the OCH, ODUKP, and ODUKT layers are used to indicate that the upstream signals are not connected to the signals of their trail termination source. So first we analyze for the optical layer. At the OCH layer, if input and output disconnection is detected for X milliseconds, an OCI is generated. If the input and output connections is normal or the overhead signal fails for Y milliseconds, an OCI is cleared. So values of X and Y still need future research. So that is for the optical layer. And for the electric layer, we can use the OCI at the ODUKP and ODUKT layers. So we check the OCI and determine whether the stature bits of the corresponding area, that is 110. Do you still remember? In previous courses, we learned the value for the OCI, that is 110. If it's 110, then we insert the OCI and insert the overhead of the PM and 6 TCM layers and all payloads. If you want to clear the OCI, we should make sure in the stature bits that 110 value should be cleared, should go to the normal statures. And another one should pay attention. The OCI must be cleared under digital signal failure conditions. So for LCK, we can support it for the ODUKP and ODUKT. So this one was used to indicate the upstream connection of a signal is locked and no signal passes. So if you want to know whether the stature is locked, so we should check the stature bits. The value should be 101, then it will be the locked statures. Okay, after that, we insert the LCK and insert the overheads of the PM and 6 TCM layers and all payloads. If you want to clear the lock statures, so we should clear the STAT values in this area. For example, the TCM1 source function changes the TCM1 statures value from 101 to 001. Okay, another one, pay attention. The LCK must be cleared under digital signal failure conditions. And here we have another description. For the LCK insertion has a higher priority over AIS insertion. That is, if a user configures LCK insertion and the conditions of automatically AIS insertion are met, the LCK is inserted first because LCK has a higher priority. The last two maintenance signals in the OTN, that is the IE and BIAE. For the IE, we have the OTUK IE and ODUK IE. Okay, so for the OTUK IE, if the IE bit in the SM overhead is 1 in 5 continuous frames, a DIE is generated. If the IE bit is 0 in 5 continuous frames, the DIE is cleared. So this is for the OTUK IE. And for the ODUK IE, if the received status value, that is 010, then a DIE is generated. If the received status value is not 010, then the DIE is cleared. The same, the DIE must be cleared under signal failure conditions. And for the BIAE, if the BI and BIE bits in the SM or TCMI overhead is 1011 in 3 continuous frames, a DBIAE is generated. If the BI or BIAE bits in the SM or TCMI overhead is not 1011, okay, then the DBIAE is cleared. Okay, the same. For the DBIAE must be cleared under signal failure conditions. Okay, so for this chapter, we introduced the OTN trails, and we have the OCH, OMS, OTS, OSC, OTUK, ODUK, OPUK, or client signals. And also, we introduced the maintenance signals in the OTN network, such as the ARS, OCI, ARCK, and for this page, IE and PIE.